everyone, this is Miss Samra. I'm back with my next lesson. So still I'm on 7-2. So we're learning about finding inverse. This time it's inverse of 3 by 3. All right, so what I want you to do is have your notes handy. The one I sent you when we started chapter 7. So you'll see 4 different pictures, 4 different images of a whole packet. So I want you to keep that handy because that's what we needed for today's lesson. So finding inverse of 3 by 3. All right. Idea still the same. So still just like 2 by 2. So you have to have 1 over determinant. And then you need to times that by its adjoint matrix. All right. Okay. So equation still the same. So determinant and determinant, you already know how to solve for determinant. So the only thing that's going to be different or something new for you guys, it's going to be adjoint. How to find adjoint matrix for 3 by 3 matrix. It's different than 2 by 2. So slightly, not slightly different. Actually, it has 4 different steps to follow. That's the reason I want you to have your packet handy. So let me bring in the picture. That way we can actually follow along and I can point out all the steps I'm talking about. So let's look at, hold up. Let's just take this and this and all right. Okay, these 2 images you need to look at. Still trying to learn a lot of stuff here. All right. Yeah, got it. Perfect. Seriously, I feel accomplished. Okay, now this is the 4th page. Am I right? 1, 2, 3. Yep, is the 4th page. So finding inverse of 3 by 3 matrix. So you need to follow 4 different steps. What are those steps? So here comes the first one. You need to find the minor matrix. Once you have minor matrix, then we need to find its cofactor matrix and then make it into adjoint, and last step is multiplying by 1 over determinant. So I would say the first step is the only step. I would say it's time consuming. Rest of the steps are pretty much kind of like easy thing. You already have the numbers, you just have to play with those numbers. So the first step going to be the only step that's going to have a lot of stuff involved in that, okay? So let's start off with that. Oh, I can't move the page. So the only thing I could do is I can just write on this page. Okay, so first step, finding minors of this matrix. So let's say this is my example I'm looking at. I have to find its minor matrix. When I say minor matrix, how do we do that? It means for every single element of this original matrix, you need to replace these original numbers with its minor. So it means every number in this matrix has its minor. How do we find its minor? It's pretty simple. What we do is, let's say I have to find minor for this first number. I'll show you down here. If I have to find minor for this number, what I'm going to do, I'm just going to cover the row and the column it's in. So that would leave you with the 2 by 2 matrix. So this 2 by 2, so basically just find the determinant of that 2 by 2. That would be the minor for that number itself. Okay, how do we find determinant? So multiplying these diagonals, 0 times 1 is 0, minus 1 times negative 2 would be plus 2, and this is how I find the first number or first minor. All right, so let me show you another one. So let's say if I'm looking for minor for this position, again, I would just cover the row and the column it's in. Once I see 2 by 2, just find the determinant. So I would replace this number with that determinant, which is going to be the minor for that position. Okay, same thing, 2 times 1 is 2 times 1, 2 minus 0 times negative 2, it's going to be 2. Let me show you different ones too. So this is, I'm looking at my third row. So let's say if I have to find minor for this position. Same thing, I would cover the row and the column. And once I see 2 by 2, find the matrix, or find the determinant, that would be the minor. I have another example. Let's say I'm looking for this one, cover the row, column. Once I see 2 by 2, and here you go. That's how we find the minor of that position or for the term. Here you go. Okay, let me show you the next page. Let's see if I can move that. No, I have to undo this first and then I can go to the next page. Yeah, here you go. Perfect. Doing great. Anyways, so once I have all those minors, I would replace every original number with these new numbers, which is minor for every single number. So this is my minor matrix. I would call this my minor matrix. Again, as I said before, so this is the only step that's time consuming. The rest of the steps are just like playing with those numbers. Now you just have to follow simple steps with this minor matrix. Okay, next step, finding cofactors. Simple stuff. How do we do that? So basically, it's just assigning this sign pattern to this minor matrix. And I hope you guys remember that sign pattern. So it's like plus, minus, plus. It's basically every other one. Uh, oh gosh, I messed up. Go back, go back, go back, go back, go back. Here you go. All right, so this would be minus, plus, minus, plus, minus, and plus. So basically what you got to do is multiply every number by that sign and then simplify. Once you multiply by the sign, so basically this is the new matrix going to be your cofactor matrix. I repeat, this is called cofactor matrix. Last step, which is the adjoint. Simple. Once you have this cofactor matrix, what you need to do is you just have to switch rows with column. So every single row, make it to the column. Or you can switch column into rows, whichever way you want to call it. So let me show you how. So let me just put it right by this cofactor. So what I'm going to do, so whatever I have as a row in this cofactor, I would make it as column. All right. So this is my first row. I would make it into a column. I would have 2, negative 2, 2. Second row, switch it to a column. I will have 2, 3, and negative 3. My last row, switch it to this third column. I have 0, 10, and 0. Here you go. And that's what I have here. That's one way to do it, switch or interchange rows with columns. That's one way to do it. Or another way is you can keep the diagonal numbers the same and just swap these two. Swap these two and swap these two. That could be another way. All right. All right. That's how you're going to find the adjoint matrix. So once you have this adjoint matrix, you just have to find the determinant. Why? Because isn't it the last step is 1 over determinant by the adjoint matrix? You already have the adjoint matrix. So now we need to find the determinant first. Okay, try recalling last video. So how do we find the determinant of 3 by 3? You need to pick a row. Every number from the original row is going to get multiplied by its 2 by 2 determinant. I hope you remember, isn't it? So basically that 2 by determinant is nothing else. That's just the minor for that position, isn't it? So since I already have minors up here, so what I'm going to do, I'm just going to pick original row, any original row. Let's say, oh, I can't go back. So let's say if I pick my original row, so these are the numbers from the original row. And I guess they picked the first one. Yeah, this is the first row. So they picked the first row. So this is the first number, this is the second number, this is the third number. Multiply each number by its minors. Since we already have the minor matrix, I'm not going to do that, redo the whole thing. No, I already have those numbers from this in this minor matrix. I'm just going to borrow those numbers and put it over here. So 3 is going to give multiply by 2, 0 by 2, 2 by 2. Follow the sign pattern, and that's my determinant. All right. Okay, almost there. So once you have determinant of this, so it's 1 over, put 1 over that determinant, times it by adjoint. Oh, why does it say adjugate? No, it's not adjugate. It's adjoint. So multiply by that determinant, and that is your inverse. There you go. So in the next video, I'll show you an example. And yeah, I hope this makes sense. Anyways, that example would make more sense to you guys. Thank you for watching and stay safe. Bye-bye.